what we're talking about with regards to elasticity is a relationship between supply and demand. And we're looking at how much that relationship moves relative, if supply goes up, what effect does it have on the demand? Or if demand goes up, what effect does it have on the supply? These sorts of things. And what effect do price have on that change? Or what effect does the demand for one product have on that change? So what we're doing is we're looking at this cause and effect scenario whenever we're talking about elasticity. And the most common way that we look at this cause and effect scenario is in the issue of price. And what difference do a change or a price and a change in price have on the demand for a given product? Now, here's a very simple example before we get into it. Let's assume that you're taking a drug that keeps you alive, okay? If you did not take the drug, you would die. Okay, so there's a very simple, say, for example, some sort of a cancer treatment or something like that. Now, how sensitive are you to a change in the price of that drug? So let's assume that drug cost you $10 a day, and the price of it doubled to $20 a day. Okay? It went from $10 a day to $20 a day, and you think to yourself, should I buy that drug or not? Now, if it's a drug that your life depends on, you're going to buy that drug. You might buy a slight less of it, but the fact of the matter is you need it to survive. So as a result, you're going to buy that drug no matter what it costs because your life depends on it. We say that the price elasticity to that drug, in other words, how much does the demand change if the price changes, is very inelastic. In other words, you're going to sell just as much, regardless if the price is $1 or $2 or $10 or $20. You're going to sell just as much. It's not going to have a big effect on the demand. So we say that the demand for that type of product is very inelastic. Usually, necessities have what's called an inelastic demand, meaning that no matter what the price is, people are probably going to buy it. And they might buy less of it, but not as, let's think about it from the point of view of percentages. That's effectively what we had to do. We had to say, okay, look, if you had a 1% change in the price, say the price went up by 1%, how much did it affect the demand? Did the demand decrease by 1%? Or did it decrease by 0.1%? Or did it decrease by 10%? So what we're trying to do, the way the economists try to do this in order to really get a handle on this concept of elasticity, is to look at the percentage changes, particularly with regards to price elasticity of demand. Always the question is asked, if the price were to increase by a percentage, what impact does it have on the demand as a percentage change? So a 10% increase in price results in a 5% change in demand. We know demand is going to go down. If price goes up, demand is going to go down, but does it change as much is the basic question. So what we're looking at in this chapter is an evaluation of this concept of elasticity. In other words, sensitivity. How sensitive is the demand to a change in price? In business and in economics, elasticity refers to the degree which individuals, consumers, or producers change their demand or the amount supplied in response to the price or income changes. So it is predominantly used to assess the change in customer demand as a result of the change in the good or services price. So price elasticity of demand is the common one that we look at. That's the most common assessment of elasticity, is say, if the price went up by a certain amount, what percentage does it change the quantity demanded? Price elasticity of demand can be defined as a measure of how much the quantity demanded of a product changes as a result in the change in the price. So we got change, and we're looking for that cause and effect relationship. So think about it. If a business wants to raise more revenue, should it raise its prices or lower them? Let's assume you're WestJet Okay, let's assume you're WestJet, and you're thinking about putting a price on tickets for a flight between St. John's and Toronto, let's say, okay? WestJet needs to think about if it jacks up its prices, let's assume the prices went up by 10%, okay? If prices go up by 10%, what impact is that going to have on the number of bums in the seats? Will people buy less tickets if the price go up by 10%? So the real question is, from a WestJet perspective, they're not so concerned about will all the seats be full. They're really asking the question, will I make more money or will I make less money? If I drive up my prices by 10%, I need to realize that let's assume 100 people will fly at the current price, okay? So 100 people will fly at the current price, whatever the current price is. If we bring up the price, let's assume the price goes up by 10%, that means the number of people that fly is probably going to go down because people are going to say, no, it's too expensive now. Ultimately, what WestJet is concerned about, though, is will they make more money? So let's assume that the price of a ticket is $100. I need to do simple math, okay? They sell 100 tickets in the first scenario, in the original situation. They sell 100 tickets at $100. So that's $10,000. So they make $10,000 revenue on that flight at that price point. And then they say, okay, I'm going to bring up my calculator now because let's say, for example, that the price of the ticket goes up by 10%. So now the ticket's $110. So let's say that at $110, they're going to sell 99 seats. Okay? 99 seats. 99 seats. Let's see now. 99 seats times 1.10. So they're going to make $10,890 on that flight. That's the revenue that's going to come in. So you're going to ask yourself, should WestJet jack up their price by 10%? Well, you don't have to be a rocket scientist to know that if you charge $100 a seat, you'd sell 100 seats, and that's $10,000. If you charged $110 a seat, you'd sell 99 seats, but your total revenue would be $10,890. Your total revenue is higher by charging $110 than it is by charging $100. So yes, go ahead and put up the prices. That makes sense, okay? But let's take a third scenario. A third scenario is, let's assume they drive up their prices by 10%, but this time the plane is only flying with 90 people, okay? So in this case, if they brought their price up by 10% to 110, so they got $110 a seat, times 90, they're only making $9,900. So the question or the answer to WestJet then at that point is saying, no, don't increase the prices because you're actually going to lose money or you won't make as much money by charging that much more. This is the fundamental issue of elasticity, is companies need to ask themselves, how sensitive is the demand for my product to a price change? In the first instance, when I said, okay, they brought up the prices by 10% to $110, but they still sold 99 seats. The amount of change in demand was very, very, very small. Okay, they had a 1% change in the demand for the flight with a 10% change in the price. So the price went up by 10%. There was only a 1% drop in demand. What happened? They made more money by charging higher. In the second instance, they drove up the price by 10%, 10% increase in price, but there was a 10% drop in the number of people on the airplane. It went down to 90. So what we saw there is now they're making $9,900. So you'd say to WestJet, no. So the answer is it really depends. So just let me show you this little video, see if that explains it better.
There are many types of elasticity. In particular, I'll focus on the price elasticity of demand. Before I get into specific discussion of elasticity, let me ask you a question. If a business wants to generate more revenue, should it raise the price of its product or lower the price of its product? I ask because I have a friend who runs a children's bookstore, and when she found out that I was an economist, she asked me this question. Well, actually, she asked if she should be giving an educator discount, but what this really meant was that she wanted to know if she should discount or lower her prices. So generally, what would you say? Should a business owner increase prices or decrease prices in order to generate more revenue? The answer, as usual, is it depends. Think about it. When your local electric company wants to raise more revenue, it will enact a rate increase. Yet, when an airline wants to quickly generate additional revenue, it will cut ticket prices. Which approach is correct? They both are. Here's the issue. If I raise my prices, I know that quantity demanded, or the willingness to purchase on the part of my consumers, will drop. That's just the law of demand. But what the law of demand doesn't tell me is how much the quantity demanded will drop. When I raise my price, will my customers be very sensitive to the price increase, cutting back a lot on their purchases? This will be bad for me because I'd lose a lot of revenue. But if I raise my price and my customers only buy a little bit less, not reacting too much to the price increase, this is good. I'd see increased overall revenue. So the crucial issue here is to find out how sensitive my customers will be to a price change. Elasticity is a measure of sensitivity or responsiveness to price. In equation form, the elasticity of demand, or ED, is equal to the percentage change in quantity demanded over the percentage change in price. Because demand exhibits an inverse or negative relationship, elasticity of demand will be a negative number. I use percentage change to measure elasticity rather than absolute change. Let me illustrate why. If I tell you that product price has gone up by $1, this would be the absolute change. Is this a big change or a small change? It depends. What's the product? More to the point, what was the original price? Okay, look, say we're talking about a pack of gum. Originally, the price was $1, now it's $2. This represents an absolute change of $1, but is it a big change or a small change? It's actually a pretty big change. Price doubled or increased by 100%. What if we're talking about a textbook rather than a pack of gum? Originally, the price was $100. Now it's $101. This is still an absolute change of $1, but is it a big change or a small change? In this case, it's a small change. Price has increased by 1%. Bottom line is that we need to know not only the dollar amount of the price change, but also how this compares to where we started. Now, technically, the formula for elasticity of demand is the percentage change in the quantity demanded over the percentage change in price, which can be found by taking the ratio of the difference between the new and the old quantities over the average of the new and the old quantities all over the ratio of the difference between the new and the old price over the average of the new and the old prices.
That looks more complicated than it is.
Frankly, I've found that if I use this version of the elasticity formula, students' eyes glaze over. People get so hung up on the math that they lose sight of the intuition and what elasticity means. So I'll be sticking to the slightly easier form and will frame my questions for you accordingly. How would you actually use this formula? Take a look at this article about the Clinton administration's proposed cigarette tax policy. If you look at the last paragraph, you'll find enough information to determine the elasticity of demand for youth smoking. Remember, elasticity of demand is the percentage change in quantity demanded over the percentage change in price. The article states that for every 10% increase in price, there's a 7% decrease in youth smoking. This means that elasticity of demand, according to the formula, is minus 7% over plus 10%, or a negative 0.7. Okay, now what do? I know that the elasticity of demand for youth smoking is minus 0.7, but what does it mean? The critical component to look at when dealing with elasticity of demand is the magnitude. How big is this number? The bigger the number, the more people respond to the price. The smaller the number, the less people respond to price. The fact that the number is negative only signifies that demand is a negative or inverse relationship between price and quantity demanded. Since I care about the size of the elasticity number, rather than the sign, let's make things easier and just look at the absolute value, or the size only, of elasticity of demand. In this example, the absolute value of the elasticity of demand is 0.7. Again, what does this number really mean, and what does it tell us? Ultimately, the key value where elasticity is concerned is 1. In the case of youth demand for cigarettes, the size of the elasticity figure is less than 1. Since elasticity of demand equals the percentage change in quantity demanded over the percentage change in price, this means that the absolute value of this ratio is less than 1. It follows then, in order for this ratio to be less than 1, it must be the case that the size of the price change is greater than the size of the quantity change. What this tells me is that it takes a relatively large price change to initiate a relatively small quantity demanded reaction. In other words, if the elasticity of demand is less than 1, people don't react much to price changes. They're insensitive to price changes, or their demand is inelastic. Question: does this make sense that where cigarettes are concerned, people don't react much to price changes? Note that the article specifies data for youth smoking. Do you think that youth sensitivity to cigarette prices is any different from adult sensitivity? Which group would respond more to a price change, youth smokers or adult smokers? If you thought that youth smokers would respond more to a price change than adult smokers, you're right. Adults tend to have more disposable income, so a price increase affects them less. In addition, the nicotine addiction is likely to be stronger for someone who's been smoking longer. This means that the size of elasticity for adults will be even smaller than the magnitude of the elasticity of demand for youth smokers, indicating a smaller reaction to any price change. One last question for you regarding inelastic demand. If the absolute value of the elasticity of demand is less than 1, that is, people don't respond much to a price change, would you raise your price or lower your price to generate more revenue? Well, the demand for electricity is inelastic. When the price changes, people tend to purchase about the same amount of electricity. We don't like the rate increases, but other than trying to conserve a bit here or there, we continue to consume the electricity. This means that the electric company could raise prices quite a bit and not see very much decrease in the quantity demanded. As a result, total revenue, price per unit times the number of units sold, will increase overall. What if the absolute value of the elasticity had been greater than 1? That would mean that the absolute value of the percent change in quantity demanded over the percent change in price is greater than 1, which could only be true if the size of the quantity change is greater than the size of the price change. So having a value of the elasticity that's greater than 1 indicates a relatively large quantity demanded reaction to a relatively small price change, or demand is elastic. Question: if it's a case that demand is elastic, would you raise your price or lower your price in order to generate more revenue? Answer: well, demand for airline tickets is fairly elastic, meaning that customers react a lot to fairly small price changes. So by decreasing prices a little bit, the airlines will see a relatively large increase in quantity demanded, or ticket sales. Overall, this would yield greater total revenue. Is it possible for elasticity of demand to be equal to 1? Technically it is. If so, the size of the quantity change is going to be equal to the size of the price change. The changes exactly offset one another. That is, a 10% increase in price results in a 10% decrease in quantity demanded, and there would be no change in.
The problem with elasticity is it sounds much more complicated than it is. And, fundamentally, as I say, it all comes down to, do our revenues go up if we change our prices? That's what companies are going to ask in the real world. That's the business case for it, right? Is if I change my prices, what impact is it going to have on demand? And ultimately, will it increase or decrease my revenues? So the question that we really have to work out in economics is to understand why sometimes revenues will go up if we drive up our prices, whereas other times revenues will go down if we drive up our prices. It's not always guaranteed that an increase in revenue is going to result in increase in an increase in price is going to result in the increase in revenue. Not always. And the reason for that is this concept of elasticity, because if people are easily, if it is easy for people to say about a given product that I'm not going to bother, then that means that people are very sensitive to price changes. And if they're sensitive to price changes, that means that if you drive up your prices, your revenue is going to go down. Whereas if people are insensitive to price changes, in other words, they got to have it, like gasoline or electricity or stuff like that, driving up the price is going to drive up your revenue. It only makes sense because you're still selling about as much and you're just charging more for it. So you're going to jack up the price. I got two cases here to kind of illustrate this. We've got let's assume that we've got a product, for example, and we're selling it for $50. And if we sell it for $50, so here we are selling it, we can charge this price $50. The demand for it in terms of whatever we're selling, let's assume is tickets of some sort. So 50 times 100, our total revenue will be $5,000. Now, if it's a type of product that people are going to buy regardless, they're going to go to it because they got to buy it, they like to buy it, they're not going to change their habits, whatever. There are any numbers of reasons that what we call makes demand inelastic. But let's assume that we charge $51 for it now. We're going to change it to $51. Now, granted, demand will drop. It will drop because people are going to say, oh, no, I can't afford it. Someone's going to say inevitably, no, I can't afford it anymore. But look how much the demand dropped. It went from 100 down to 99, which is a 1% drop and about a 2% change in the price. Okay? And because the price change was a greater percentage, in other words, the percent change in price was 2%, the percent change in quantity was 1%. In other words, price moved a lot more than the quantity. We've got an increase in revenue. That's going to mean, we're going to make $5,049 by charging that. So this is what we call inelastic demand. In other words, and this calculation that she was talking about there is the percentage change in, okay? The percentage change in price. If we compare the old price and the new price, it went from 50 to 51. So it went up by 2%. If we look at the change in the quantity, it went down by 1, which is a decrease in 1%. And this decrease in quantity was less than the increase in price. So revenue went up. In the second scenario, here we got almost identical scenario. We got a $50 item. We're going to sell 100 of them. So that's $5,000. You're going to yield $5,000. Let's assume that the price went up to $51. Okay? But in this case, so that's a 2% increase in price. But look what happened here. We went from 100 down to 98. So this is a 2%, two and a little bit percent change in demand. And what we're saying here then is the price change was really 2%. The demand change was 2% plus 2.1%. So demand changed more. The percentage change in demand was greater than the percentage change in price. And this is what happens. We had $5,000 in revenue before. Now we only got $4,988. Not that much difference, but the fact of the matter is that we saw revenue decrease. And this indicates what's called an elastic demand. And I always think of elastic demand and prices for items that we don't really need. We can buy substitutes for them, or we can say, it's no big deal. If I can't get it, I can't get it. So, airline travel is an example. Do I need to fly? I'd like to, but that don't mean I got to. It's not life and death, right? So this is really important for businesses, because they need to know that if I change my prices, it's going to have an impact on my revenue. And the question is, depending on the type of product and the environment I'm working in, it's either going to increase my revenue relatively or decrease my revenue relatively. And it depends if you got an inelastic demand for your product. Inelastic demand, people are going to buy just as much of it. So that means our revenue is going to go up. Or an elastic demand where people say, heck with it, I don't need it. And that means your revenue is going to go down. So just in terms of stuff that only makes sense here, total revenue is price times quantity. And elastic demand means that quantity demand is quite responsive to a change in price. Elastic demand means quantity is not that responsive to a change in price. So if demand is elastic, price and total revenue move in opposite directions. If demand is inelastic, then the total revenue move in the same direction. Price and total revenue move in the same direction. So we got this formula here, and really the price elasticity of demand is driven by this formula that she just put up on the screen, which is the percentage change in quantity. This little triangle means percentage change, change in, change. So the change in quantity demand, this is the percentage, this combination here is the percentage change in quantity divided by the percentage change in price. And in order to get that, to be able to calculate the percentage, what we do is we take the absolute change in the quantity, okay? We went from this number of units to that number of units. So whatever the difference is in the number of units between the original price and the next price, divided by the average quantity. In order to figure out the average quantity, we take the original quantity and the new quantity, we add them together and divide by 2. In other words, we get the average. So it seems complicated, but we're doing the absolute change in quantity divided by the average quantity. And we do exactly the same thing in the bottom in terms of the calculation. We take the original price and the new price, and we figure out what the difference between the original and the new price is. This will give us our change in price. And then we take the original price less the new price and divide it by, we take the original price and the new price, we add them together and divide it by 2. We get the average price. So in order to do this, we need to understand how to do the math. So the math is the percentage change in quantity divided by percentage change in price. So here we go. Let's look at this table right here to take a look at it. So here's product A. I'm just going to focus on product A. The original price was $5 and the new price was $6, okay? So what we're doing here is we're saying, okay, let's look at this situation here. The our revenue, okay, let's look at our total change here. Percentage change in quantity demand. Okay, let's look at our change. So we got original quantity and we got our new quantity. Okay, and we ask ourselves, what's the difference between the original and the new? 60 minus 55 is 5. And then we have to say, well, divide it by the average quantity, and the average quantity is 60 plus 55 is 115. Divide 115 by 2. So in other words, the average, or you can simply say, let's hit the number halfway between this number and this number. Okay, same thing. You can take the average of it, or you can take the number as half. Both are exactly the same. So this is 57.5. We divide here. We got the quantity divided by the average, And that's an 8.7% change in quantity. So what this is saying is the percentage change in quantity demanded in the first instance was an 8.7% change. In other words, prices went up by 8.7%. Okay. Then we do the same thing. We do the same, or quantity, I'm sorry. I used the word price. I shouldn't have. Quantity went up by, now we look at the price. So what was the original price? What is the new price? Let's look at the price. The original price and new price. 5 to 6. So what's the difference? 1. So there was a difference of 1. What's the average? 6 and 5. So 5.5 is in the middle. So that's an 18.18% change in price. So we got to, okay, we don't have to go any further with the math, really. We can just ask ourselves, look, what percent, how much did the percentage change in quantity? 8.7%. How much did the price change? 18. So our price change was a much higher quantity, much higher number, our percentage, than our quantity demand. So price basically doubled the quantity. So if we do the mechanics of that, we'll get the, this is what you call it as the coefficient right here. Coefficient is 0.48. That doesn't mean a darn thing. It's better to do it intuitively and say, look, what changed more, price or quantity? The price changed a lot. Quantity didn't change as much. So that means that you can change the price a lot, but people, that's inelastic. That's what I call inelastic, because the price went up a lot, the quantity didn't change that much. This is what's called an inelastic demand. And I got product C. I must have skipped B. I didn't have enough room. So anyway, so here's product C. Let's just take a look at product C. First, we look at percentage change in quantity. The quantity started at 60 and it went to 30. So the difference between 60 and 30 is 30. The average is 60, halfway between 60 and 30 is 45. 60 plus 30 divided by 2, 45. So that's the percentage change in quantity was a 66.67% change in quantity. And then we say, okay, what's the percentage change in price? 5 to 6. So that's an 18% change in price. So we had a 18% change in price caused a 67% change in quantity. Wow. Relatively small change in price caused a big change in quantity, right? The price change wasn't as great as the quantity change. This is what we would consider an elastic demand. And if you do the math on it, in fact, the coefficient of elasticity is actually 3.67. In other words, quantity changed by 3.67 times more than the price. So this is what you would consider an elastic demand. This is what you would consider an inelastic demand. Inelastic is a number less than 1. Elastic is a number greater than 1. But again, I don't like going any further in the formula than right here, because all you need to do is compare. Was the price change bigger than the quantity change? If the price change was bigger than the quantity change, as in what happened here, that means the price can change a lot, but we got relatively little change. That's by definition inelastic. If we ask ourselves, what was the price change here versus quantity change? Wow, we had a big change in quantity for a given change in price. That's what you call elastic. This calculation, when you look at it in the textbook, and you look at it even here, that calculation, the percentage change in quantity demanded, or the percentage change in quantity price, that looks so complicated where it's presented in the book. Let me get the book and show you. They don't do a very good job in this book of...
Paul?
Yep.
I'm just wondering if you could possibly repeat, how do we find our denominator when it comes to this type of question?
Okay, well, let me... How do we find our denominator? Well, both of them are found the same way. Look, if you look at the in the book, like there's the formula looking at. Look, that looks like a massive wow, something out of some PhD. But that's not complicated. It's presented as being complicated, but it's really not. Because what we need to do, what effectively we're asking ourselves in this, and this is why I said I don't want to get lost in the math, okay? what we're effectively asking ourselves whenever we think about price elasticity of demand. If anyone asks you, well, what is this concept of price elasticity of demand? Well, effectively, what it's asking you to do is to say, let's compare the percentage change in the quantity demanded of the product, which is the denominator, okay, with the percentage change in the price, which is the denominator. So what we're doing is saying, how much did the quantity change and how much did the price change? And let's compare the two. That's effectively what we're doing here with this. So this little formula right here, or the way that this is presented, is the way it should be presented in the book. But what they get caught up in is this: how do you calculate the percentage change in quantity demanded? Okay, and this is what gets confusing. In order to calculate the percentage change in quantity, what you need to do is, first of all, figure out what was the absolute change in the quantity. Okay, this is where this 5 comes from. So our original quantity was 60. Our new quantity is 55. So the absolute change in quantity is 5. Then we ask ourselves, in order to be able to calculate the percentage change, we need to be able to have some way of doing that. So in order to calculate the percentage change in quantity, we got to take the percentage change in quantity and divide it by the average quantity. So this number right here, 57.5, is the average quantity. And the average quantity, 60. Calculate it. Here's the simple way to calculate an average. 60 plus 55 is 115. And then we divide it by 2, and that will give us 57.5. Otherwise, we can say 55, 60. What's the number halfway between 55 and 60? 57.5. We do the math on that, multiply it by 100 in order to get a percent. That's 8.7%. Now, you ask, what is the denominator? Well, there's 2 denominators on the go. That's the denominator in that one. But in terms of this calculation, then, in order to the percentage change in quantity, the formula is percentage change in quantity over the percentage change in price. So here's the percentage change in the quantity. And I could have put a line here that's a division, but I didn't want to overcomplicate it. Okay, so this is the percentage change in quantity. Here's percentage change in price. We ask ourselves, what is the absolute change in price? The price was 5, it went to 6. 5 to 6 is an absolute difference of 1. That's where the 1 came from. And then in order to calculate the percentage change, what we do is we got to take the average price, which is no different. We had to take the average quantity. So we took the average price, 5 to 6, the average price is $5.50. Do the math on that, that comes to 18.18%. Did that make any more sense? Christopher?
Yeah, thanks.
Okay. So effectively what we're doing here, and then you ask, well, what are you doing this? What's this down here? Well, if we took this and we divided it by this, we get this coefficient of elasticity, it's called. I don't like calculating the coefficient of elasticity because it doesn't help your understanding. I like looking at it intuitively here now at this stage, and you ask yourself, look, the price changed by 18%. I'll just round number it. I don't want to get into decimal places. It's too hard. The change in price was about 18%. There was an 18% change in price. And then you ask yourself, what was the change in the quantity demanded? Well, it was about a 9% change in the quantity demanded. In other words, the price changed twice as much as the quantity. So price went up 2 times, and the quantity demanded only went down by 1 time. In other words, the price change didn't have that much of an effect on the quantity demanded, relatively. So this is what we define as inelastic demand. Now, this one over here uses the exact same formula. Notice the way that is calculated. 60 minus 30 is 30. 60 plus 30 is 90 divided by 2. In other words, what's the average? Halfway between, 45. That gives us 66%, 67%. And we ask ourselves, let's look at the price. How much the price changed? It went from 5 to 6. 5 to 6 is a $1 absolute. 5.50 is halfway. It's an 18% change in the price. Okay, so you got an 18% change in the price, but a 67% change in the quantity. Wow, relative to the price, quantity changed a lot. And because quantity changes a lot, this is what we define as an elastic demand. So we can draw these things. And so effectively, all I've done here is I've done the math on it. You could actually draw your demand curve, and you're going to see that the demand curves for product A is steep. Demand curve product C is not so steep. Okay? And well, what does that mean? That means, well, because it's so steep, you can say that, look, a change in price will cause a relatively small change in quantity. Just by definition, if we drew a line over here and we smashed it off and we draw another line here, look, this gap, in other words, the change in quantity, is not that different than the change in the price. When you get a line that's a relatively shallow line, in other words, it's pretty flat, look, here's our change in price, and look what effect it had on quantity. The gap here is much greater than the gap here. So small change in price, big change in quantity. Small change in price, even smaller change in quantity. So the more flat the demand curve, the more elastic the demand. The more tall or the more vertical the demand curve, the less change. So it becomes more inelastic.